So if we were wanting to do a practical investigation to see the movement of materials in the xylem, the specialized tissue for the transport of water and dissolved mineral ions from the roots up to the leaves, we want to see that this movement actually occurs only in one direction and where it's actually going to. So our aim for this investigation is to investigate the direction and the structures through which water and dissolved dye will move through some celery. All right. The hypothesis would be then that water and dissolved nutrients are just transported by the xylem tissue in stems. Now, the way that we're going to try and figure this out is, rather than using just plain water, we're going to use this thing called eosin. So the label's gone there a bit. Let's see if we can, there we go, eosin, a lovely bright red solution. We're going to set up our celery. And eosin solution. And we're going to give it a little bit of time and come back and see where this water dyed with eosin is traveling. Okay, so we have left our celery in the eosin, so in there, celery in the eosin for the last day or so. And what you can see is that you can clearly, if I can just get that in focus, you can see that there's some red dots here. So we're going to assume, based on the fact that we know that xylem is transporting water and dissolved nutrients, that must be the xylem that's colored that way. But now what we're able to do now, remember on our roots prac, when we looked at the cross section of our roots, that we could see that there were vascular bundles. And I said in there, we're going to do a prac where we're going to see which is which in there. Okay, so we're going to identify it now using this, and you can see how all of the water has actually made it to the leaves, the place, the site where photosynthesis is occurring, needing that water. And that's actually quite a neat little experiment to show that. And we're going to just have a look on the microscope now. Okay, so now what we've done is we've removed our celery, we've cut a thin slice so that the light from the light microscope can actually get through our sample, and now we're able to see, here's the outer edge of our celery, now we're actually able to see the parts that are stained red. That is, the parts that we know are the xylem, because they're the ones that are taking our water and dissolved nutrients up to the leaves. And that's actually what we saw. We saw these lovely stained red leaves because we know that eosin dye has actually gone up, traveled up along using the cohesion of water, as in water, because it's a polar molecule, it's got that hydrogen, the oxygen there in the middle, highly negative, and our two hydrogens, because it's H2O, very positively charged, and because of that it's a polar molecule. One side of the cell is actually got a different charge to the other, so that actually allows it to stick to the lignified walls, the walls of our xylem, the dead cells, and it's actually able to travel up like a straw. And also what's assisting in that is the fact that water likes sticking to itself. So any water that's being pulled out, that's why it's able to get pulled up against gravity. up to the top of the tree or up to the top of the plant. Now we can see in here, if you look at your thing here, so this is in, again, aligned to an investigation in your book. Let me just double check that I've got the right page here. Page 171, so it's practical 6.1 or investigation 6.1, 171 to 173. Okay, and if you're looking along with me there, you'll be able to see now that this is a vascular bundle. This here, if you can see my cursor, is a vascular bundle, and IS capture has just died. Great. Oy vey. Bear with.
One eternity later.
And we are back. Ready to go. Actually, I've unplugged my mic.
Eventually.
And we are back. So, like I was saying, let me just go to full screen. Like I was saying, we can now see we've got our epidermis here, right? Palisade cells here, densely packed together, needing to do some photosynthesis. And then we've got our ground tissue here, which is pretty much the bulk of the stem. And then we've got our vascular bundle here. Now this is at our 40 times magnification, so it's quite a big grouping of cells here. If I was to go closer to 100 times, we're not really going to get heaps more information. Sorry. I'm doing this everything with fine focus because I'm not next to the microscope, so it's taking a bit longer. We're not getting actually heaps more information by doing it this way. Okay, so I'm not really that concerned about looking at it like this. For this prac, oopsie, what's going on? Looking at it like this, is more than okay. Now, what I might do just to help you get the contrast, actually see which part of this really is xylem and which part of this is phloem, because what's ended up happening is, because I've left the plant for a long time just between doing all other things, you can actually see that there's a bit of red in the phloem, which means that our water has gone up to the leaves, been used in photosynthesis, and now has been able to travel back to the rest of the plant through the phloem cell. So that's why the phloem's got a bit of a red tinge as well. But for some reason I can't get out of, there we go, full screen. So what I'm going to do actually is I'm going to come over to here and go to color control and put up the red a little bit. And you should start to be able to see a little bit more of a contrast there. So now you can see this part here is our xylem, right? And here is our phloem. And in our phloem, there's a whole variety of other things going on, like companion cells and sieve tubes to allow bidirectional movement. But in our xylem, it's really just a tube, a straw, a wooden straw taking up our water up there. Now, sorry, I had the questions prepared. So, what I want you to do is to, I have gone to the wrong page. What a good video. The questions are: explain the purpose of the eosin dye in this experiment. Describe how the dye is distributed in the plant. Has the whole stem turned the red color, or is the dye found only in particular places? Can you please explain your answer using this evidence from the video? Describe the appearance of the xylem tubes. Suggest what causes the dye to travel to the leaves. And was the hypothesis supported? As in, did we actually see that it would just be that area colored red? To help you with your answer, go to page 170 and click on the link called Transpiration Cohesion Tension Theory. Transpiration, cohesion, tension theory. Rolls right off the tongue. Easy peasy. So that's page 170. Use that link and the information presented there, including on start of page 171, to help you work through this prac and learn a bit more about xylem cells.